Good afternoon. Thank you all for being here. I'm amazed at how many people stuck around to listen to this part of it. I'm not going to get technical, but I am going to talk to you about why I'm interested, why the Office of Naval Research is interested in autonomy and in these types of competitions, and all of the things that we've done to help them grow, and the latest thing we're trying to do, which is the use of simulation environments to enhance the performance of these vehicles. So I'm going to start off with a little infomercial to talk about Robo Nation. Daryl Davidson is the executive director of Robo Nation, and he is here in the back of the room. You might want to talk to him a little bit more about Robo Nation throughout the afternoon and the evening on the break and at the Gala Awards tonight. But they have a grant from the Office of Naval Research to execute several of the objectives that they have as Robo Nation that matches the objectives that the Office of Naval Research has. But Robo Nation is more than just them. It's a collection of students, such as those of you who have competed in this competition. It's a collection of educators and a collection of industry leaders and other partnerships. So Robo Nation is truly a partnership, and I invite you all, by virtue of you being here at this competition, to become part of Robo Nation. Many of you have been to other competitions that are already part of Robo Nation, and so you already have your badge of membership. What's pictured here in the first picture with students is the Georgia Tech team who compete in RoboBoat and RoboSub and the Maritime Robotics Challenge. In the middle picture with educators is a number of judges who come from subject matter expertise either in academia or industry or government. And then the industry picture portrays the first Robot X held here in Singapore. And I think the lead guy there is Ministry of Missions from Japan. Next picture. So, Robo Nation has a mission, and it is to create a pathway whereby hands-on educational experiences can empower students to find innovative solutions to global challenges. That's a big statement, and it covers the waterfront, but they do it through a series of gradual exposures to low level, to higher and higher levels, and higher levels of challenges. But through starting with a STEM activity, science, technology, engineering, and math, through their CPERCH and CY program, they advance them from remotely operated vehicles or pre-programmed vehicles to pure autonomy in multiple domains. So starting with the STEM program, they have two premier programs. One is CPERCH, and that is a partnership with the Office of Naval Research. It came from a book written by Harry Beam from University of Vancouver called Underwater Robots, and it's a yellow book, and you can buy it online, and if you can't find it, I have 10 extra copies that I would be happy to send you. But it's basics on pressure vessels, and basics on controls, and basics on propulsion, and it is all remotely operated, but there are a series of lessons that go with it, and from that the CPERCH was born. MIT used this for their introduction to ocean engineering for their freshman students, and one of the professors had a student who was in middle school, had a child who was in middle school and was playing along the river in one of the canals with the CPERCH unit. And a teacher came by and said, "That's really interesting, what is that?" So this professor went back to the university and to the Sea Grant program and said, "I really think we have something here that could expand and be used at all levels, not just the freshmen entering MIT." And so they proposed to the Office of Naval Research to use this as a way to attract students into wanting to learn more about the studies of underwater systems and underwater maritime autonomy. So about 20, I hate to say how old I am, About 20 years ago or so, I spoke to the owner, program officer, because I was with one of the Navy labs at the time, and said, I would really like to take this program forward. And I picked two great mentors who had a proven track record. And I said, if this program could be scalable, viable from a national effort, these two people could help us prototype it, could help us demonstrate it at the local level and move beyond that. They were quite successful. As I mentioned this morning, we've reached well over 250,000 students. The real test for it is that although the students matriculate through the system and leave, the teachers want to use it year after year. It meets a number of educational objectives in the school system. It's adaptable. You can do it in a classroom. You can do it in an after-school activity. We have a culminating event, this National Grand Challenge for Sea Perch annual. This year it will be in beginning of June held at the University of Maryland. Typically, we've had as many as 50 to 100 teams in the last couple of years. We've had over 200 teams that have to qualify at a regional level and then come and compete with them. We've started a STEM Expo associated with that competition to encourage students to what is the next step. If you liked what you did, this is autonomy, and we have all sorts of demonstrations, hands-on demonstrations of things you can do to move into the next steps. So, with that, it leads me to then flourish with Robo Nation, start with the STEM activity, and then move through a series of activities that Robo Nation supports that have competition elements to them. There are air competitions, SUAS, IARC, a ground competition, IGVC, and in the maritime environment, there's Robo Boat, Robo Sub, and Robotics. I'm going to speak more today about Robotics in general. And we had the first Robotics competition here in Singapore at Marina Bay Sands in 2014. There were 3 teams each from 5 nations, 3 from Singapore, Australia, South Korea, Japan, and the US. After that, we wanted to expand to perhaps a number of up to 25 teams and add additional nations. Marina Bay Sands is a limited waterway, and in order to have the real estate to go beyond that, we moved the competition to Hawaii. We've held 2 competitions there, one in 2016 and one in December 2018. The Maritime Robotics Challenge has 3 components to it. And in addition to this every other year physical competition, we noticed a fall-off in interest in that intervening year. So in 2017, we created an event called the Robotics Forum. We're looking for another name for that. So if you have any suggestions for us, we also use the word forum to designate the online chat room and discussions that we have with each of the other competitions. And so that gets to be a little bit confusing nomenclature. So we're banding about some names for this event, which we hope to hold in December in 2019 in Singapore. So we're holding discussions this past week, and we'll continue, and we hope all of you will consider attending that once the details are posted. The third element is the Virtual Robotics Challenge, and that's really what I wanted to talk to you about today. We noticed that teams that spend a lot of time in the water or in the environment actually operating their vehicle do the best in competition. That's sort of a given. And so I encouraged all of you this morning to get in the water as soon as you can and get as much in-water time as you can. Don't wait till you come to the competition and have that be your start time. However, we noticed a second tier of teams that might be water limited. They might not have the permitting, they might not have access to water, it might be frozen half of the year, and so they can't get access to the water for whatever reason. But we noticed that those teams that created simulation environments had a leg up on teams that either didn't get in the water or didn't have these simulation environments. When we moved to the Robotics Challenge, the single platform of the Wave Adaptive Modular Vessel, which you see in this next picture, we noticed that a lot of teams were comprised of naval architects, mechanical engineers, electrical engineers, and a lot of them said they had problem recruiting computer scientists or people to do the coding. And so we thought if we created a separate event, this virtual challenge, it could give teams a way to recruit additional members to their teams. Because this event, and in all areas of maritime autonomy, it is truly multidisciplinary. And so being able to have a specific task, a specific goal, a specific standout challenge for the computer scientist group really helps. So we designed and are still working through the competition details, but you will see we have created in the gazebo environment a wave environment that has wave, wind, sunlight conditions. We are only doing surface vessel tasks, and the tasks are traditional naval, the navigation channel, doing path following, winding through a path and obstacle avoidance, identifying obstacles, also docking in a station based on identifying shapes and colors, and pretty much what you will see in the competition. There will be a standard WAM-V platform with standard propulsion, 2 thrusters to offer differential steering, and then a bow thruster to help with control. The student teams will be able to outfit their WAM-V with a set of standard sensors. So they can choose the sensors that they think they can use or that represent their vehicle in trying to move through the tasks. As we know, there's not a one-for-one correlation in an idealized simulation environment to working in the real environment. But if you can't do it in the simulation environment, you're probably going to have additional challenges in the real environment. However, if you can do it in a simulation environment, in the virtual environment, you're going to have a leg up. You're going to understand how your algorithms need to work, how your systems need to talk to one another, what data your sensors are collecting, and how that is filtering through the performance of your mechanical systems. So in the real world, you want to sense, you want to perceive, you want to make decisions, and then you want to execute. In this environment, we have included wave conditions, wind conditions, lighting conditions, and those are all the challenges to the idealized environment. And so we're hoping to offer an environment that challenges you, but also prepares you then for the real environment at the competition. So there is an application process. We didn't want just anybody who's a computer scientist who isn't working with a maritime systems team to apply. So we didn't want 2 guys in a computer in their closet working on this. So what we are doing with the application process is having you apply at www.robotics.org. The launch site, the landing site for this application process opens on Monday in the US. So you guys have advanced knowledge as to when that's going to happen. So you should go online and you fill out an application that includes your reasons, the past history you have, how you will use the virtual environment to enhance your performance in the real environment in any of the competitions. It could be the SAUVC or ERL competition in Europe. It can be the competition you were here today. It can be Robotics. It can be RoboBoat, RoboSub. But just how you will use your exposure to this virtual environment and apply it to a real vehicle. We will accept up to 40 teams to compete in the competition. The competition will be run in stages. We will open the cloud environment in July. You will know in April if you're one of the teams selected. And that link will take you to other links that will take you to the software side of things and the development. So we've been working with the Naval Postgraduate School, Dr. Brian Bingham, and the Open Source Robotics Foundation. The Open Source Robotics Foundation is developing ROS, and they also run competitions for DARPA, NASA, NIST, and other organizations. So they will be running the competition in the cloud. You will provide to them all of your algorithms, and then they will run them through the various environments, do the automated scoring. And in December, when we meet back here in Singapore for the Robotics Forum, or whatever we're calling it at the time, we will be announcing the winners. We will also at that event have sort of a hackathon. So we will have another element in real time to this virtual event. With that, I thank you for your time, and I open up the floor to any questions you might have.